Today we're going to solve multi-step inequalities. All right, again, some of the same standards we've been looking at: create, solve, and represent equations and inequalities, and be able to look at solutions both algebraically and graphically. All right, to be successful with this lesson, you need to be able to use more than one property of inequality to generate equivalent inequalities, solve multi-step inequalities using inverse operations, and apply multi-step inequalities to solve real-life problems. All right, example 1 says solve each inequality and graph the solution. All right, let's look at A part. It says y divided by -6 plus 7 is less than 9. So we're going to do our inverse operations. The first thing we're going to do is subtract 7 from both sides. So we're going to have y divided by -6. Our 7's cancel, bring down the inequality. Since we're adding or subtracting, the inequality stays the same. 9 minus -7 is 2. Now we're going to multiply by -6. Multiplication is the inverse of division, so that will cancel that. Because I multiplied by negative, remember I have to switch the inequality symbol. 2 times -6 is -12. All right, in order to graph this, I'm going to go by 4s. All right, so I got -12. I need to open circle at -12, and it needs to be greater than -12. All right, B part. 2v minus 4 greater than or equal to 5. I'm going to add 4 to both sides. So I've got 2v. -4 and +4 cancel. Bring down my greater than or equal to symbol. 4 plus 5 is 9. Divide by 2. V is greater than or equal to 4.5. 2 goes into 8 4 times. 1 left over. 1 over 2 is 1/2. 1/2 is the same as 4.5. All right, so to graph my solution, I'm going to have greater than or equal to 4.5 means I have a solid circle here. Greater than or equal to is going to be to the right. And it's going to be everything bigger than 4.5. All right, open-ended question. It says write 2 different multi-step inequalities whose solutions are represented by the graph. All right, so first thing, open-ended questions are often difficult for students because it's just what it says. It's open-ended. There's no exact right answer. You just have to play with the numbers and come up with one that meets this requirement, okay? So let's just play with numbers. So we know we have to have a multi-step inequality, and we know the solution has to be all numbers less than -1. So multi-step, that means we got to have at least 2 things happen before we get to -1. All right, let's just kind of think backwards and see if we can write an inequality. All right, so let's go from -1. Let's say we add 4. If we add 4, we're going to end up at 3. If we're at 3 and we divide by 3, we're going to end up at 1. All right, let's see if we can make something work. All right, so let's say we've got 3. Let's say we got 3x plus 4. And then we need this to be less than -1. But let's see what we need in this spot. So we're going to subtract 4 from both sides. So we're going to have 3x less than. To have a 3 here, we need to have a, oh, well, if we put a 1 here, that gives us a -3. And then if we divide by 3, that does give us -1. All right, so see if that works. All right, so 3x plus 4 less than 1. Subtract 4 from both sides. 1 minus 4 is negative 3. Bring down your 3x. Divide both sides by 3 to solve for x. X is less than negative 1. This says x is less than negative 1. This is an inequality that meets that requirement. Okay, so sometimes you just got to start with something and then kind of work backwards. All right, it does say write two different multi-step inequalities. I want you guys to do the second one on your own. So just think of numbers, think about where you need to end up and kind of add and multiply to get to a different place and see kind of if you can play with numbers to where you can write an inequality, but you end up with x less than 1 as your answer. All right, the next example, we're still solving multi-step inequalities, but now we have a variable on both sides. So example 2, solve 6x minus 5 less than 2x plus 11. You can see as the inequalities get longer, now they're not really asking us to graph these as much, but you can still always graph these if you want to show your solution set. All right, so we're going to start by subtracting 2x from both sides. We want to get our variable on one side. And if you've been with me long, you know that I like to try to make my variable positive if I can. So 6x minus 2x is 4x. And then I'm going to minus 5. And then I bring down my less than 11. So let's add 5 to both sides. 4x is less than 16. Divide by 4. X is less than 4. And again, if you wanted to graph this, this would be an open circle and it would have an arrow shaded left of 4. All right, the next one says 8b minus 3 greater than 4 times 2b plus 3. The first thing we're going to do here is distributive property. So 4 times 2b is 8b, and 4 times 3 is 12. All right, I have 8b on both sides, so I'm going to subtract 8b. So I have negative 3 is greater than 12. Is that a true statement? That is not true. Negative 3 is not greater than 12 ever. So this is not true. Since this is not true, there is no solution. So there is no number that you could plug in for B to make this work. All right, the next one says 2 times 5w is 10w. 2 times negative 1.2, that should be negative 2.4. We're going to have less than or equal to 7 plus 10w. And I'm going to subtract 10w from both sides. My variables cancel again. I have negative 2.4 is less than or equal to 7. This one is a true statement. Because that is true, this means this has all real numbers. So all real numbers are the solution. So that means it has infinitely many solutions. So similar, you can have no solution, or you could have all real numbers as a solution, or you could have a solution set like we've been solving for in previous examples. All right, solving real life problems. You're playing a trivia game on your cell phone. You need a mean score of at least 90 points to advance to the next round. What score in the 5th game will allow you to advance? All right, so what score in the 5th game will allow you to advance? And we want a mean score of at least 90. Remember, mean is the same thing as average. Okay, so the first thing is you just have to understand the problem. All right, so you're going to work this problem exactly like you would if you said Miss Lily, how many or what score do I need to make on the next test to get at least a 90 for the 9 weeks? Okay, so you're given 4 scores. What does your next score have to be to get at least a 90? So you would work that the same way as you will this trivia. Okay, so we're going to look at it. We're going to say we got 95, we got plus 91, plus 77, plus 89. And then we have a 5th game that we don't know yet. So we're going to call it X. All right, so we got 1, 2, 3, 4, 5 scores. And we need the average to be at least, okay, at least, so 90 or higher. So we're going to do greater than or equal to. All right, so we can add these 4 scores up. Let's add these 4 scores up and see what we get. Okay, my calculator has a mind of its own. I don't know why it doesn't want to move for me. There it is. All right, so we're going to do 95 plus 91 plus 77 plus 89. So that's the 4 scores that we know. So that's 352. So 352 plus x over 5 greater than or equal to 90. All right, now we're going to multiply both sides by 5. Let's get rid of our fraction. Okay, so 90 times 5, 450. So we got 352 plus x. The 5's canceled, so I'm left with what's on top. So I'm going to subtract 352 from both sides. X is going to be greater than or equal to. All right, so you can see that that's only 2 off from the 100 difference there, so it's going to be 98. So they're going to have a score of 98 or higher to average at least 90 points for this trivia challenge. All right, and again, that would be the exact same thing if you asked me what you needed to make on a test. If you had those 4 scores for test grades and you had 1 more test remaining and you were trying to get a 90. So again, this is useful, very useful to be able to set up if you want to kind of know how hard you need to study for your next test.